Okay, so in this video, we're going to take a look at different ways we can represent a function. So we're going to take a look at 5 different ways that we can represent a function. We can represent a function as a formula or an equation. We can also represent as a table of x and y values, as a mapping, as a set of ordered pairs, and as a graph. Okay, let's take a look at a couple of examples. So the first one, we are given explicit formula for the function f of x equals to x plus 1. Then we're gonna represent this function in the 4 remaining ways. So add the table of x and y values, set of ordered pairs, mapping, and a graph. Okay, let's start by figuring out the tables of x and y values for this function. Okay, so we've got x here, and then y is 2x plus 1. So let's do that, and we're gonna do a bunch of different points here. All right, so I'm gonna start with -2, -1, 0, 1. Then I'm just gonna do dot 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 down here, which means that this pattern is gonna continue all the way. Okay, so now when I plug in -2 for x, so I'm gonna get 2 times -2 plus 1. So this is 2 times -2 is -4 plus 1 is -3. Now you don't actually have to show this work. Okay, you can directly give the y value here, and that's what I'm going to do for remaining x values. So now I'm going to plug in -1 for x, so 2 times -1, which is a -2, plus 1 is a -1. And then for 0, 2 times 0 is 0 plus 1 is a 1. And then for 1, 2 times 1 is 1 plus 1 is a 2. Okay. And also I'm going to do dot 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 on the right side too, just so that it means this pattern is going to continue all the way. Okay. So this is the table of x and y values. Okay. Let's write this as a set of ordered pairs. So as a set of ordered pair, we can write this function as f equals, and then all we gotta do is write them as set of ordered pair from this table of x and y value. We already got it. Okay, now you always want to write the set with curly braces and then ordered pair with parentheses. Okay, so the first one is -2 comma -3, and then separate each of them with a comma. The second one is -1 comma -1. The third one was 0 comma 1, and then 1 comma 2, and then again we're going to do dot dot dot, just so that it means the pattern continues. Alright, so that's the set of ordered pairs. Now they can also represent it by a mapping, so I'm going to draw a mapping here. So the first one, that's going to be my input. The second one is going to be my output, so here. Alright, so input, I'm going to list the x values that I have, and then again put dot dot dot. So -2, -1, 0, and then 1, and then I'm just going to do dot dot dot. And then for y values, it's -3, -1, 1, then 2, dot dot dot. Now I gotta give the name, and then it's f here, so I'm just gonna do f here. And then draw arrows to represent the correspondence. So -2 maps to -3, -1 maps to -1, 0 maps to 1, and then 1 maps to 2. Okay, so that's the mapping representation. And then the last one we're gonna take a look at is representing this function as a graph. For that, we're gonna need a grid. Alright, so we got the grid here. Let me scale these x and y axis here. So I'm gonna go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's gonna be -5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So Right, so you want to scale accordingly based on what numbers you have it here. And then you want to use actual graph paper. Okay. All right, so I'm going to take a look at the set of ordered pairs from up here and then use those plot those points and graph the function here. So -2, -3, so 1, 2 to the left and 3 down. All right, so somewhere here. The next one is -1, comma -1, so -1 down -1. The third one is 0, comma 1 here, and then 1, 1, comma 2, so 1, comma 2. Alright, so and then join these points with a straight line, and that is going to be the graphical representation of this function. So you got one representation as an explicit formula or an equation that's given to us, 2 the table x and y values, 3 the set of ordered pairs, 4 as a mapping, and then 5 as a graph. Okay, let me show you one more example. So here we're actually given the table of xy values, and then we're going to have to represent this function in the remaining 4 ways. Okay, since we are given the table, let's write this function as a set of ordered pair. Then we are not given the name, so just let's keep the name ourselves. Let's call this function f and write the set of ordered pairs just from the table. So 1, 3, 2, 6, 3, 9, 4, 12, and dot dot dot. Right. Let's also do the mapping representation, because we know all the, well, not all the, but some of the inputs and outputs. We'll just use dot 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 to extend those ordered pairs. So again, the name of the function is f. Got 1, 2, 3, 4 for input, and then I'm just gonna do dot dot dot, and then 3, 6, and 9, and 12, and dot dot dot. And then to complete the mapping, we've got to draw these arrows. 1 goes to 3, 2 to 6, 3 is being mapped to 9, and 4 to 12. Okay. All right. Let's graph this, and again, we're gonna need a grid for that. We got a grid here. I'm gonna scale my x-axis first. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. I'm gonna have to go up to 12, so I'm gonna go by 2 this time. So this is gonna be 2, 4, 6, 8, 10, and then this would be a 12. I don't actually have any y values that are negative, but I'm just gonna go up to -6, just to show all this scaling along the axis. Okay. All right, so let's plot these points. 1, 3. So 1, remember this is going by 2, so 2 and 4, so 3 would be in between. So that's going to be 1, 3, 2, 6, so 2, 4, 6, so here. 3, 9, 3, again, this is 8, this is 10, so halfway in between would be a 9. 3, 9, and then 4, 12, so 1, 2, 3, 4, 12. All right, and then finally gotta join this point with a nice straight line. Again, you guys should use ruler when you're doing this. Okay, and that is the graphical representation of that function. Let me write y equals f of x right now, because we don't know the explicit formula yet. All right, so the last one is, well, we gotta give the explicit formula or the equation. So for that, we're gonna go back and look at the table of x and y values, and then try to find the pattern here. So as I'm seeing is, the y value is always 3 times the x value. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 12 is, sorry, 4 times 3 is 12. So the pattern or the rule is, for the y value, multiply the x value by 3. So f of x equals 3x would be the explicit formula for this function. Or you could also write this as y equals 3x. All right, so I hope you understand 5 different representation of a function, and you can represent a function in all those 5 different ways, given one of the 5 different ways. Thanks for watching.